So reciprocal identities, we already know what these are. We know our reciprocal pairs. Cosecant of theta is the same as 1 over sine of theta, right? We already knew that sine and cosecant were reciprocal pairs. So this is kind of just stating something that we already knew, and then we're just going to use it today in a different way than we have in the past, perhaps. Okay, what is paired with secant of theta? Secant's pair is cosine. Good. So secant of theta is the same as 1 over cosine of theta. And cotangent is paired with tangent, right? Good. So 1 over tangent of theta is another way to write cotangent. So we're just looking at another way to write these trig functions. So the same thing goes for the next row. Sine of theta is equal to 1 over cosecant. Question?
Couldn't you also do cosine over sine?
Yeah, we'll get to that next. Those are actually called quotient identities, and these are the reciprocal pairs. That's right. Okay, sine is 1 over cosecant. Cosine is 1 over secant. Tangent would be 1 over cotangent. Okay, so those are, again, identities we really already knew. We just didn't know we knew them as an identity. Again, we have a couple more quotient identities because tangent and cotangent have multiple ways that we can write them. And we did this a lot when we were using the unit circle and we needed to calculate the tangent of each angle. We would do sine over cosine. So tangent can also be written as sine divided by cosine. And notice that I'm always writing theta. Theta doesn't have to be the variable that's used. It could be, x. You might see alpha or beta or gamma. Any different variable, there's several different variables that can be put in that place, but we always have to have some variable, meaning that's what represents the angle measure. So tangent is sine over cosine. Cotangent would be the opposite of that, which is cosine over sine. So we're writing these down in one central area so that we can always refer to this and we can use these different rational expressions to substitute in place of other things in hopes that we'll be able to simplify and eventually be able to solve equations. All right, now here's the new stuff. The Pythagorean identities. There's really 3 of them, and if you have that purple card, you'll see one particular form in which they've written those 3 new Pythagorean identities. So these are the 3 new ones. And the reason that they're written like this is because we can move the terms around. The identity is simply an equation, and we can move the terms around and solve for different things in order to be able to substitute it in an equation when I need to try to help out. So what we have is sine squared plus cosine squared equals 1. This is the most commonly used trig identity. We're going to use it quite a bit in several different forms. Now, underneath, you see 2 other forms because if I wanted to or if I needed to, I could add or subtract these other terms to other sides. For instance, if I wanted to subtract the sine squared theta from both sides of this equation, I could do that. That would eliminate the sine squared from the left. So I would be left with cosine squared theta equals 1 minus sine squared theta. So I've just taken the same identity and I've moved things around, and now it looks a little bit different. So I'll be able to substitute it in perhaps somewhere that I need to. So that would be this one down here. 1 minus sine squared is equal to cosine squared of theta. So don't think of it as more things that you have to remember or more identities that you need to memorize. Just know that you know how to move things from left to right in an equation, and you're allowed to do that in any form as long as you follow the rules. As long as you use the sign that's directly in front of that term and then use the opposite operation in order to move it to the other side. So this next one, or the one here in the middle, what took place was the cosine squared was subtracted from both sides of the equation. So that left us with 1 minus cosine squared theta is equal to sine squared theta. So these are not the only ways that they can be written there, but they are a couple of common ways that we can rewrite the identities. And similarly for the next two. So there's three main Pythagorean identities. The first one being sine squared plus cosine squared is equal to 1. Then we have secant squared minus tangent squared equals 1. And cosecant squared minus cotangent squared, and it also equals 1. So then we can move terms around if we want. And then let's say if I'm trying to solve an equation, and in my equation I have something that looks like this. It's cotangent squared of theta. In my equation then, I could replace the cotangent squared with this expression, cosecant squared minus 1. Maybe I have some other cosecant terms that I would be able to add it to or subtract it from or possibly multiply. We'll see those examples as we go through the packet. But the whole reason for having these is so that we can substitute them in place of different terms in order to simplify or prove or solve an equation of some sort. Okay, so let's take a look at how we're going to put these to use. And we're going to move to the next page and take a look at number 2. Okay. Number 2, cosine squared of x times, you don't see anything there, but that is a multiplication between those two. So cosine squared of x is being multiplied by cosecant of x, and then subtract another cosecant of x. So the notes at the top here give us some examples of what to possibly look for when you're trying to simplify them. It's really hard for you to have any idea what you're trying to do because you've not seen these before and you really don't know what you're looking for. You don't know what I'm telling you to do. So we're just going to have to look at some examples so you can see what we need to try. It says when we're simplifying, use the identities, use algebra, substitute and rewrite each expression in its simplest form. The hardest part is knowing what is the simplest form. How far do I go and when is that enough? Ultimately, you've gone far enough if you can get it to be written in only one trig function. So see, like right now, I have like 3 terms here. well, really just 2 terms, but 3 parts. If I can do stuff to this and simplify it so that I just have one trig function as my final answer, then I know I've simplified it successfully. If you're having a hard time doing that, you might want to try to look and see if you can rewrite things in terms of sine or cosine. We use sine and cosine the most. And so if it's possible to substitute in place of individual terms and change it somehow to sine or cosine, then you know you're headed in the right direction. So what I'm looking for here in number 2 is, what can I replace? Sine and cosine are my favorites. They're the ones I go to, the ones I try to convert most things in terms of. So I'm going to look to see if it's possible for me to do something with this here, with these cosecant terms. Now, I could put something in its place, like 1 over sine, perhaps. But I also, because I've been doing this quite a bit, I know what they're looking for, which is an advantage for me, but a disadvantage for you in this case. And here we have one term, here we have another term, and those 2 terms have something in common. They actually have a greatest common factor. They have something that they share, and I can factor it out. The cosecant of x. See how it's here in this term and it's here in this term? I know I have 2 separate terms because of the fact that they're separated by that subtraction sign. So I can factor out the greatest common factor in this particular expression. I can take out the cosecant of x. And when I factor cosecant of x away from this first term, I'm left with cosine squared of x minus
G or C?
C. And then when I take the cosecant away from this term here, what's left over?
1.
A 1. Good. A 1. It feels like nothing's left. It feels like it's empty or blank. But remember, in math, when we think it's nothing, it's almost always 1 that's in that spot. Okay, great. So here's my first step. My first step was I factored out a greatest common factor. Now it just so happens that inside the parentheses, I have an identity. One of my Pythagorean identities is represented by cosine squared minus 1. So flip back over and look at your list of identities and tell me cosine squared minus 1 is equal to what? Cosine squared minus 1 is equal to what? Yes, cosine squared minus 1 is equal to sine. So I can put sine squared of x in place of what was in that parentheses there. I'm going to hang on one second. So my identity would be sine squared plus cosine squared is equal to 1. So if I subtract the sine squared, yes, actually, very nice. From both sides, I get cosine, very good, 1 minus sine squared. Then subtract the 1 over here. Very good. So it's actually a negative sine squared. So let me get rid of all this. And so we'll put this inside here. We'll do a negative sine squared. So these two are being multiplied together. And cosecant is equivalent to what? How can I rewrite cosecant? Cosecant is the pair of sine, so that would mean cosecant's the same as 1 over sine. And then I'm going to copy down the rest of what I have. The negative sign squared would be over 1. And you might notice it at this point that it looks like I have something in common. I might be able to cancel. I'm going to go ahead and multiply straight across the top and then straight across the bottom. And then let's see what we have available to cancel. So it looks like I have one of the signs that can cancel. This sign of x in the denominator can cancel out with one of the signs that's on top. So it's going to just leave me with one negative sign of x left over. And now that I have it simplified down into one trig function, I am actually finished.
How did you get all that? What was the first page of notes? Trigonometry identities, and then I don't know how you got all that.
Well, what I have to start, with one small thing and try to substitute something in place of it. And how do you know what to pick? You don't always know. And sometimes you might pick something that doesn't work and you have to start over again. It's just the trial and error.
Let me see. XCX. How did you go?
Cosecant of x, cosecant is the same as 1 over sine.
What was the first page of notes?
And up here at the top, it tells us that cosecant of theta is equal to 1 over sine.
And what is the circle or zero? Why is that?
Theta. That's theta. It's the symbol theta.
Okay.
It's kind of like an egg shape with a arc through it. Okay. Pythagorean identities. What about them?